GCSE Physics, Electricity Lesson 16, and this is power, current and voltage. The objectives are to recall the power equation and to apply it. So there's an equation that links electrical power, electric current and voltage. And it's this one: electrical power is current times voltage, or P equals IV, or P equals VI, whichever. Electrical power is measured in watts. Current's measured in amps, and voltage is measured in volts. If you want to pause and get that down. So let's do some calculations. So on these questions, if you want to pause and then have a go, and then I'll take through the answers. So the first one's relatively straightforward. Calculate the power of a 230 volt television that draws a current of 2.8 amps. So P equals IV. So power is current times voltage. Then just multiply the numbers. So current is 2.8 times a voltage of 230. Pop that in your calculator. Give 644 watts. Let's move on to another one. So you want to pause and have a go at this. Calculate the current drawn by a kettle of power 1.5 kilowatts when connected to the mains 230 volt power supply. So on this one, you can do P equals IV, and if you're good at maths and confident with the letters rather than the numbers, you can just rearrange to get current. So divide by V, because obviously they're multiplied. So current is equal to power divided by voltage, and then just put the numbers in. If not, we can have the equation in its original form and put the numbers in straight away. So power is 1,500 because it's kilowatts, 1.5 kilowatts times 1,000, equals the current, I times V, which is 230. Then we just need to make I the subject, so we need to get rid of the times 230, and to get rid of a times 230, we divide by 230. So 1,500 divided by 230 will give us 6.5 amps. Alright, let's do some more. So let's pause and complete this table. So for the first one, P equals IV. So simply multiply the numbers together. So we've got 230 multiplied by 5, which is 1,150 watts. Let's look at the next one. So number 2. So P equals IV yet again. This time we're getting current, so we need to divide by voltage. So the current is 4,600 divided by, now this is a big voltage, 230 kilovolts, so 230,000. So the current's going to be exceptionally small. And it is at 0.02 amps. Let's do the next one. So number 3. So P equals IV. So I want voltage this time, so we need to do power divided by the current. So the power is 0.48 divided by the current of 4 milliamps. So to get from 4 milliamps into amps, we need to divide by 1,000. So that's 0.004. So put that into our calculator to get the voltage we get. 120 volts. And let's look at the last one to get power. So the fourth one. So P equals IV. So the current is 200 kiloamps, which is 200,000 amps. Multiplied by the voltage of 6 megavolts. So that 6 mega means million. Which gives us some obscene number, which would never happen in real life. You can blame me for picking mega and kilo in the same question. So 1, 2, that's got 3, 6, 9 to 11 zeros. Watts. Yeah, that's likely never going to occur. But if you got it right, well done. Alright, let's move on. Now these ones should work. So what I want you to do is to calculate the missing sections on this table. So I'll do an example just so you're sure. So the first one, so they've all got 230 volts, and the first one's running at 400 watts. So the current is obviously power divided by voltage. That's from the P equals IV. So we need to do 400 watts divided by 230 volts to give us the current, which is 1.7 amps. Then what we need to do is decide which fuse you're going to use. So would you use a 3 amp, a 5 amp or a 13 amp? So you want the fuse that's just above the value which you've got for your current. So in this instance we would use a 3 amp fuse. So to do that 3 more times and then calculate the maximum possible power that comes from a device that uses a 230 volt mains. Okay, and then I'll go through the answers. So you can pause. So the microwave will be 800 watts divided by 230 volts, which gives us 3.5 amps. So we would use a 5 amp fuse. The next one, it's got a 15 watt charger. So that would be 15 watts divided by the voltage of 230. And that's 0.07 amps, which is obviously small. So that's obviously a 3 amp fuse. And then a 2.5 kilowatt heater. So 2.5 kilowatts is 2,500 divided by the voltage of 230, which gives a relatively large current of 10.9 amps. So the fuse choice would be a 13 amp fuse. Maximum power available, let's P equals IV. So if the maximum current allowed in a mains is 13 times the voltage of 230, gives us a maximum power output of 2,990 watts. So if you're more than that, you might need a double plug setup, or it might need some kind of special wiring like a cooker, for example. The only time I've seen a double plug set up in a house is a carpet cleaner. It will clean my carpets. So that run at 5 kilowatts. So it needed 2 plugs to obviously get more than the allowed 2,990 watts. Right, one last thing then, let's do a closed exercise, just a bit of recap, consolidation. So you can either write this out in full, or write 1 to 8 and just put the keywords in the correct place. If you want to do it without the keywords, you can attempt it now. If you want the keywords, I'm going to put them on in a second. And then I'll take you through the answers. So electrical power is the rate of conversion of electrical energy to some other form and is measured in watts. Electrical power is equal to electric current multiplied by voltage. The greater the power for the same voltage, the greater is the current drawn. The correct fuse for a device is the next available value above the normal current drawn by the device. The maximum fuse rating for a 3-pin plug is 13 amps for an appliance of power of about 3 kilowatts. So hope you found that useful. Thanks for watching, and I'll see you at the next lesson.